Today we are doing section 8.6. We are slowly but surely getting towards the end of chapter 8. Today we are going to talk about natural logarithms. So we will evaluate expressions, solve equations with natural logarithms. This is not a whole lot different from what we've been doing. It still has to do with logarithms. All those properties we talked about still apply. We're just going to be using a special base, which makes these special logarithms. So you might be asking yourself, what is a natural log? A natural log has a base of e. Remember that natural number e that we talked about when we were looking at interest? Yes. The a equals p times e to the rt. Remember that little e? Same little e. We're just putting it as a base on the logs. So this is something we've already talked about. E is an irrational number approximately equal to 2.71828. A natural log is written ln. So it's like a lowercase l, lowercase n. Some of you saw that on a maze worksheet that I'd passed out at one point. Some of you might have seen it on your calculator. So the big idea here is that log with a base of e is the same thing as ln. We call ln the natural log. All right. The properties of common logs apply to natural logs. You should see that in bold on your guided notes. So those properties that we learned, the power property, the product property, the quotient property, all of those still apply. These are just a special type of log. It's just written with an ln instead of an log. So if we are condensing these or writing them as a single log, a single natural log, we use those same properties. So what can happen with the 3 that's out in front? Where can it go?
In the front.
It is in the front. Exponent on the 6. So this can become the natural log. I usually write mine cursive so that I know it's an L, not a 1. The natural log of 6 cubed minus the natural log of 8. But if I want it as a single natural log, that means I just want to write the ln one time. How can I condense subtraction? Using division. So I'm going to take what divided by what? 6 cubed divided by 8. Now, I can evaluate 6 cubed. 6 times 6 times 6 is what?
Oh, I got the whole.
216. And then 216 divided by 8 is that the 27?
Yeah.
So this becomes the natural log of 27. On example 2, what rule or rules are we going to be able to use here?
Power and product.
Power and product. The power rule is going to do what? Make a 3 an exponent on what? Why not the y? Okay, it's not in front of the y. It's only in front of the natural log of x. So it only belongs to that one, not both of them. Okay, so that was the power rule. Some people also said we could use product rule. So this is going to condense it down to one natural log of what?
X cubed
Over
over y.
y? X cubed times y. So if you want to put the times dot there, you can. You do not have to. And then it's written as a single natural log. We are finished. On number 3, what rule or rules can we use? Power and product again. How are we going to use the power rule? For the 1/4 where?
In front of 3 and 1/44.
In front of?
Oh, behind, sorry.
Over.
Oh.
As an exponent.
Yeah.
Be careful with how you're saying these. In front of means to multiply. Behind would mean to multiply. On top of would mean to divide it. It's an exponent. If you are precise with how you word things, you are less likely to make mistakes later on when you have to do these on your own. So, the natural log of 3 to the 1/4 power plus the natural log of x to the 1/4 power. Okay, what else? Multiply them together. Now, on this type of problem, I would recommend changing your 1/4 powers into 4th roots. But if you were to get this far at this point, I'd be happy about it. 3 to the 1/4 times x to the 1/4. Really, that's going to be the same as the natural log of the 4th root of 3x. This would be the best answer. Maybe even at this point get you a bonus point. But if you could at least get to natural log of 3 to the 1/4 times x to the 1/4, that at least shows me that you used the properties appropriately. If they're both being raised to the same 1/4 power, we're taking the 4th root of both of them. All right, on number 4, what property or properties can I use? Power and quotient. How would I use the power property? Okay, 2 becomes an exponent on 12. We have the natural log of 12 squared minus the natural log of 9. What is 12 squared? 144. You said I could also use the quotient rule, which means I'm doing what to the 144? Dividing it by 9. 144 divided by 9 is?
16.
So this gives me the natural log of 16 as my final answer. Some people only miss like a point on problems because they would get so far, like they would have 12 squared over 9 with their log, but they didn't evaluate it. If you're given variables, that's fine. You can't really do anything with that. But if you've got numbers, you can take 12 squared and you can divide it by 9. We should always simplify these if we can. All right, next up in our notes, natural log equations. You can solve natural log equations similar to the way you solved common log equations. However, instead of using a base of 10, you must use a base of e. So when we see ln, and we are told to change it to exponential form, we have to know that the base is e. Just like with the common log, if we didn't have a base written, we knew that the base was 10. It's the same idea. Moving along, we've got a couple examples at the bottom of that front side of your notes. First one, natural log of x is equal to 0.1. We are going to switch this to be an exponential form, just like we would have done before. What's my base? E. The natural number e. What is my exponent going to be? Nope. 0.1. Remember the exponent, when we switch to exponential form and we get rid of the log, it brings the base back together with what's on the other side.
Is that
Yes, this is my natural number e.
sorry,
And this gets set equal to what? X. Questions about how we set this up? Got rid of the log by switching it to exponential form. Now what do you think we need to use?
E.
our calculator. So on your calculator, you should already know how to find E because we needed to use it when we did those interest formulas. So we are going to get E up on our calculator and raise it. So it should pull up a caret for you usually when you type in E. Raised to the 0.1 power.
It says it's 1.
You shouldn't have to close your parentheses, but you can if you want to, since we're not doing anything else to it.
Mine says 1.16.
Yes, 1.1052 if we round to 4 decimal places.
Is that what you want?
All right, let's switch number 6 to exponential form. What is my base? E.
21.
Raised to the 21st power equals
Minus 9.
3x minus 9. First thing I need to do,
E.
And yeah, do the E.
do the e to the 21st power.
That's a long one.
It's a big number.
It is a pretty big number.
13, 18, 8.
Oh,
Is that numbers?
that's like the doom.
It's a big number.
That's like
I would consider that a big paycheck, so I would consider it a big number.
No, that.
What are we going to do to that number?
Add 9.
Add 9 to it. Let's make it a little bigger.
Divide by 3.
And then we, yes, would divide by 3.
so x equals 4, 39, 16.
Add 9, divide by 3. Still a big number. So x equals,
40, 96.
Is that like a trillion or?
I'd be fine if you rounded that to the whole number. 48 at the end, that's fine. Let's see.
How do you put the planet in?
I said I rounded it to the whole number.
Oh,
So on a number like that, that's fine. That is a large number. 439,605,248.
yeah, around
No, if you put the 7.8 at the end, that's fine. I just ran out of room. Questions about how we did that problem?
Yeah.
All right.
1 point?
Number 7. What is our base?
You got that point?
E.
Base of e raised to what exponent?
12.
Equals
X plus 2 divided by 3.
x plus 2 over 3. We have to evaluate what first?
E.
E.
E to the 12th.
E to the 12th power. We got a somewhat large number. What is it? 0.79. I'm going to leave the 1 4 on there for now. Equals x plus 2 over 3. Next up,
Multiply it by 3.
multiply by 3. So I'm just leaving that number up on my calculator screen. And then I'm going to press the multiply by 3 on the calculator while that's still on there. So times 3. So now we got an even bigger number.
4, 8, 8, 2, 6, 4.
0.37. Mine still has that 4 3 on there.
Minus 2.
And then we're going to make that number just a little bit smaller.
Subtract.
Minus 2. Now, if your number is this large, like we have a very large number, and you round to a whole number, I'd probably be okay with that because we've got a lot of digits. When we had those really small numbers, I wanted 4 decimal places. I'll be a little flexible with these. So if we've got like 488,262, I'd be fine with it. If you left the 3743 on the end, that's also fine. And that is equal to x. So who got number 7 right? Oh, I would have liked to have seen more hands. What went wrong with number 7? What part about it was confusing? Was it getting started on it? Let's talk about number 8. What's my base? E again, we've got a natural log. It's got a base of e. We're raising e to what power? 4th power, and we're setting it equal to 3x plus 5, that whole thing squared. That squared traps all of that stuff that's in parentheses together for now. So we should evaluate what?
E to the 4th.
E to the 4th. That's a much more manageable number.
54.5981.
9. I'll put the 2 on the end to round up. We're going to round that one. Okay, equals 3x plus 5 squared. So we had some question about what step comes next. If I'm telling you that the squared is trapping the 3x plus 5 together, I need to undo the squared, which means I got a square root. I do that to one side, I do it to the other side. So I just kept that number on my screen. I'm going to press second root and then second answer. If you need help knowing how to do that on your particular calculator, that's fine. That way you don't have to type that number back in. But you should have gotten something along the lines of 7.3891.
Yeah.
And that's equal to 3x plus 5. Okay, this comes to the part where I think people should know what to do. We subtract the 5 on both sides. We have 2.3891 equals 3x. And then divide by the 3. So if you've been doing all this in your calculator, the minus 5 equals, you should have that number up on your screen. Press divide by 3 equals, and we get x equals what?
0.796350902.
So rounded to 4 decimal places would be 0.7964 for x. So we can also solve exponential equations involving e. We can use natural logs to solve any exponential equations involving the number e. I know it seems weird to refer to e as a number, but somehow we've all become comfortable with calling pi a number, so why not e as well? So these ones are going to be more like what we did most recently, where we take a log of both sides. So remember, the natural log has what base? No. E. So I'm just going to write this one way first just to show you why this works. Okay, we are going to be taking the natural log of both sides. But what that means is that if I take log base e of e, what do you think that equals? 1. So that's the same thing as taking the natural log of e. Log base e is natural log. So the natural log of e is going to equal 1. Does this make sense? We're just writing it a little bit differently so we don't see both of those e's at the same time. So when I go to number 9 and I say we need to take the natural log of both sides, I am implying that I'm using what base? E. So I take the natural log of both sides. 2 things are going to happen on the left. What's going to happen to my exponent?
Go to the front.
It's going to come out in front. So the x plus 1 stuck together comes out in front. The natural log of e simplifies to be 1. And then on the other side, we've got the natural log of 30. What's nice about the natural logs on this type of problem is that we don't have to do a change of base because we have an ln natural log button on our calculator. So x plus 1 times 1 is x plus 1. Natural log of 30 we can find by pressing ln on the calculator, 30, enter.
Oh, so we y'all want E instead of ln?
Yep, we're just using ln. Typing it in the way it is. So 3.11, or so 1, 2. That works. The 9 makes that second one go up to a 2. My last step is 2. Subtract that 1. So x equals 2.4012. Do we have questions about this? Again, everything we've done today has been highly related to stuff that we've already done. We're just doing it with a natural log, so it's got a different base. Are we ready for number 10? If I put it up there, number 9 disappears. Are we okay with that? Okay, there it is. As a reminder, I will rewrite the fact that the natural log of e is equal to what number? 1. So I'll rewrite that as a reminder. You might want to write that somewhere in your notes. What is the first thing I should do on number 10? Jacob?
I just got a question.
Oh, question. What?
Did you use the product and all that on these problems?
No, because we don't have any logs in there right now. We add the logs ourselves later, but we can't just put them everywhere we want them. Does that make sense? Okay. So what should I do first instead? Subtract the 2.5. 7e to the 2x equals 17.5. And then divide the 7 off. We're trying to get it as simple as we can before we have to use our natural logs. So if we take 17.5 divided by 7, what do we get? 2.5. So e to the 2x equals 2.5. I'm going to take away number 9 and show the rest of my work over there. Are we all okay with getting e to the 2x equals 2.5? Once the e is alone, what should I do to both sides? What is it?
Bring the 2x.
Bring the two.
I can't bring the 2x in front yet. What am I missing? We need to use the natural log. That's what we're missing. We've got to use the natural log if we're going to use those rules that I keep hearing people say. So we have to take the natural log of both sides. If I don't see you put that in there, then none of these other steps that I hear people talking about are going to make a whole lot of sense. We got to have a log in there to be able to use these properties. So now that we have the natural log in there, what can we do with our exponent? Bring it out into the front. And now that we have the natural log in there, the natural log of e is equal to a 1. And then on the right side, we're going to be able to evaluate the natural log of 2.5. 0.9163. And then the last step, divide by 2. Good. X equals 0.4581. Last example. We got to get it copied down by number 11. Just by looking at this, what do you think my first step is? Good. Subtract off that 7.2. So that leaves me with e to the 2x divided by 5th power equals what? 1.9. Now that I've got the e alone, what should I do?
Get e to be 1.
How do I do that? Natural log. We got to take the natural log of both sides. natural log of e to the 2x divided by 5 power equals the natural log of 1.9. Now, what happens with our exponent?
It goes to the front.
Okay, it can come out to the front. So we've got 2x over 5 times the natural log of e is 1 equals the natural log of 1.9. That means that we've got 2x over 5 equals what? 0.6419 or 185, whatever. I don't always round right away here, so if you want to leave a few more decimal places on the back of that, you can. 886 if you want them all. Now what do I have to do? Multiply by 5. So I would just leave that number up on my calculator screen and hit times 5. So 2x equals 9. Sure, if you round here, it would round to a 3. I would try to avoid rounding a whole lot until the very end. We're almost to the very end. What's our last step? Divide by 2. Here is where I would definitely round. Again, that number's in my calculator, so I just hit divide by 2. 1.6046 would be correctly rounded. Questions about number 11? We all get a copy down? Ready for the homework slide? Okay, our homework comes from page 646. 1 through 7, all of them, and 14 through 28, all of them. I did get the PDF up on Classroom. I will add the assignment details in just a moment.